Great. Hi there, Scott again from EdgeMath, and I'd like to go through a real analysis concept, or it's a fancy word for real analysis. It's um, formalizing calculus. So you might see this in an advanced calculus class, or some of the students I've have had it in their first year calculus class, but it's useful for economics and many other subjects. But so let's talk about existential and generalization quantifiers. So it's just fancy words for things that sort of make sense in plain English. So we've got this upside down A, which is for all, and then this backwards E for there exists. So let's do an example problem of how this notation can help. So for example, let d2x mean x is divisible by 2, and d8x mean x is divisible by 8. And now use the existential and generalization quantifiers to express this statement. If x is divisible by 8, then it is also divisible by 2. So for example, 8, 16, 24, 32. Those are all divisible by 8. But of course they're also divisible by 2. So since 8 is a multiple of 2. So we can do it like this. Let's see. So we're saying for any number x, if x is divisible by 8, then it's divisible by 2. So that's any x, or all x. So we can write for all x, and then if x is divisible by 8, that's d8x. So if x is divisible by 8, then that implies x is divisible by 2. So we can write that even in a way a computer could read. So a computer couldn't read this English. If x is divisible by 8, then it's divisible by 2. But we could train a computer to read, or program a computer to understand this sentence. So for all x, if x is divisible by 8, then x is divisible by 2. Now let's use so we just use the generalization there. Now let's express this statement. There exists a number that is divisible by 2, but it is not divisible by 8. So for example, 6, that would be an example. 6 is divisible by 2, but not by 8. So there is some number that's the exists. So there exists x, some number x, such that we can write this semicolon, such that, or colon, I guess. So there exists x such that x is divisible by 2, but x is not divisible by 8. So let's find out how to connect those. But we've got x is divisible by 2, but x is not divisible by 8. So both of these are true. So we can connect those with and. So there's some number x such that x is divisible by 2, but, and x is not divisible by 8. So we say not d8x. this is, so this is and here, and not, and this can be read as such that. So that's a couple examples of how we can use these for all, and there exists quantifiers to write some sentences that are kind of easy to say in English, but using this syntax, or kind of like a language, we can write it in a more formal way, in a way we could program into a computer, or even someone in a different language, and Russian or Chinese could understand. So great. If everything's good with that, let me know if you have any questions. And this is Scott from Edge Math signing out. Have a great day.